Welcome to my YouTube channel Raise Acad. Myself Yash Mishra, and we were seeing in chemical bonding hybridization. So in hybridization, what was there? In hybridization, there was mixing of orbitals. Mixing of orbitals. Okay. So when mixing of orbitals is there, there is hybridization. Okay. So a formation of new compounds are there because of hybridization. So when the, and also one main thing is, when the valence band theory, VBT, valence band theory, when it fails, then the concepts are explained by the hybridization. Okay. So when valence band theory fails, so we explain by hybridization. Okay. So these are the main things we have to know for the hybridization. And there are three types of hybridization. What are the three types? There are sp3, sp2 and sp. These are the three types of hybridization which are there: sp3, sp2 and sp. So the geometries, we will see what are the geometries involved in this hybridization. So geometries involved in hybridization. Okay. So what are the different types of geometries involved in the sp3, sp2 and sp hybridization? So in sp3, it is tetrahedral geometry. Okay. So a tetrahedral shape, as we know, for example, say sp3 hybridization we find in methane gas or CH4. So this is a CH4 molecule, and if we draw, how we will draw? This is H, this is H, this is H, and this is H. So approximately this angle is 109 degree. Okay. So between two H atoms of methane gas, the angle is 90 degree, 109 degree. Okay. So, and the geometry which is there is tetrahedral geometry. So like this, elements are attached in the methane gas. So, and the geometry is tetrahedral. Hybridization is sp3. Second hybridization is sp2. Geometry is planar triangular. Okay. We see sp2 hybridization in C2H4. Okay. So C2H4 molecule has this sp2 or planar triangular shape or geometry, and sp hybridization is having linear shape, linear geometry. Okay. So the sp hybridization has a linear geometry. So these are the three types of hybridization, and we saw the geometries involved in the hybridization: tetrahedral, planar triangular and linear geometry. Okay. So these were the three types of geometries involved in the hybridization. So now in the hybridization we saw mixing of orbitals, how the orbitals are mixed in the hybridization. Okay. So mixing of orbitals in hybridization. Okay, so in firstly the hybridization was sp3 or the tetrahedral geometry it was having. So sp3 hybridization, there are one s orbital, as we see one s orbital mixed with 3 p orbitals. Okay, then the sp3 hybridization is formed. Okay, so next was sp2 hybridization. sp2 hybridization, so in this one s orbital is mixed with 2 p orbital. Okay, then the sp2 hybridization is formed, and now we can easily predict what is sp. When one s orbital is mixed with 1 p orbital, then the sp hybridization is there. Okay, so these were the mixing of the orbitals, how the s and p orbital mix, and the hybridization is there in the molecules. So as we saw the examples of hybridization were sp3 ch4 tetrahedral shape, and sp2 c2h4 planar triangular shape, and sp c2h2 linear shape. Okay, so these are the 3 types of hybridization, and the main thing in the sp2 and sp hybridization we should know is that sp2 hybridization, one pi bond is there, one pi bond is there. Okay, so in the sp hybridization one pi bond is there, and in this isomerism also happens. So what are the isomerism which are there in the sp2 hybridization? They are cis and trans type of isomerism. Okay, so these are the 2 types of isomerism, cis and trans, which happen in the sp2 kind of hybridization. Okay, so these are the 2 types. So for example, the molecule was C2H4. Okay, so this was the molecule, and if these 2H atoms are replaced by 2, for example 2 CH3 atoms, okay, or CH3 ka whole twice, so what the molecule becomes? Molecule will become like this: C double bond C, this CH3 here, another CH3 here, and this H and H. So this type of system is called cis isomerism system. Okay, or cis isomerism compound. Okay, so this, when the 2 CH3 atoms are in the same site, then it is called as a cis isomerism or a cis type of system, and this is a pi bond. Okay, and one more thing, that the p orbitals which are involved in sp2 hybridization are perpendicular to plane. Okay, so this sp2 hybridization or in orbitals, the p orbitals which are there are perpendicular to the plane or perpendicular to the s orbitals. Okay, so for example, this is the pi bond. Okay, so these are the p orbital, like this p orbitals will be there, p orbitals. Okay, so like this the p orbitals will be there and they will form 90 degree with plane. Okay, so like this the p orbitals orientation will be there. Okay, so we saw the sp2 hybridization, how the cis isomerism is there. And now for trans isomerism, how it will be there? For example, this is C double bond C, this is CH3, another CH3 will be in the opposite side, and these are the 2H atoms. Okay, so this is the trans of that, and showing the sp2 hybridization in C double bond C. This is sp2 hybridized carbon. Okay, and this what carbon is this? This is sp3 hybridized carbon. Okay, and this is also sp3 hybridized carbon. Okay, so these are the hybridizations involved in this. So now let's see what is sp hybridized. Sp hybridized. Okay, so as we saw, the geometry is linear, and what we saw the example, C triple bond CH, C2H2. Okay, so 2 pi bonds are involved, and it is having a linear shape. So no cis trans isomerism. Okay, so no isomerism of cis trans it can do, because it is having a linear shape. Okay, no cis trans isomerism because of linear shape. So if you see that a particular molecule is having a linear shape, it cannot show any isomerism, because the it is having a symmetry across the across itself oriented plane, having